Okay, so we left off with our 4x4 linear system to solve for our constants a, b, c, and d. So again, from the first equation, that's really easy to solve. We see right away that a is equal to 1/9. And then we know that 6 times a is equal to 9 times b. So 9 times b, of course, is 6a. So we can now go through and divide by 3. So 3b is equal to 2a, which is 2 times 1/9. So if 3b is equal to 2/9, then b is equal to 2/27. So we've got the value of a and the value of b. Now let's work on the c and d. So for c and d, let's first combine like terms. Combining the c's, we actually have 5c minus 12d is equal to 0. And then we've got a 12c plus 5d is equal to 1. So for this equation here, we need to multiply by constants, or we can go through and try substitution. Substitution is going to throw in a lot of fractions, so let's use elimination instead. I'm going to multiply the top equation through by a 5 and the bottom equation through by a 12. So that's going to make 25c minus 60d is equal to 0. And then the bottom equation, of course, is going to be 144c plus 60d is equal to 12. Summing those up, we get 169c is equal to 12. So c is equal to 12/169. Not the prettiest constant. If we go back to our top equation, we have 5c minus 12d is equal to 0. That says that 12d equals 5c. So 12d is equal to 5 times 12/169. So 12d is equal to, that seems kind of weird. It was here. No, that's right. All right, so we got 12d equals 5 over that, so that's going to be 60/169. So d is equal to 60/12 times 169. So that's 5/169. So we've got our c, we've got our d, and we are ready to write down our particular solution. So our y of x is going to have our c1 e to the 3x plus c2 x e to 3x plus, and it's going to be a 1/9 x plus 2/27. And then we have our plus 12/169 cosine 2x plus our 5/169 sine of 2x. And that is our general solution for this problem here. Again, it's checkable. If you wanted to, you could go in and substitute this y in place of the y's in the differential equation and get a true statement.